Alright, so here we have a system of two linear equations. Normally when we're solving a system of linear equations, there'll be one ordered pair solution. The reason for that is, when we graph two lines, say this is one line, and then if we graph the other line, they're going to intersect at one point. And that point right there is represented as an ordered pair, like for example, maybe 5, 2, and that will be the solution. But if you look at this system, notice that if we were to multiply the bottom equation by a -5, if I take the bottom equation, which is negative x plus 5y equals 2, and I multiply through by -5, we end up getting 5x minus 25y equals -10. And this is exactly the same as the top equation. So the bottom equation is the same as the top equation. It's just, if we take the top equation and divide both sides by -5, with the second equation appears. So they're really the same line. These two equations represent the exact same line. And so what's going on geometrically is, that they're the same line. So we have one line, and then the second equation is right on top of it again. And so there's an infinite number of points. There's all points that are on this line are solutions. They intersect all over the place. And so of course we can't write an infinite number of ordered pairs. So the solution just turns out to be the line itself, and the solution is the line. It's the equation of the line. And we normally express it in slope-intercept form. So once we realize that these two equations are indeed the same and they're the same line, then we just solve one of them for y and we express that as the solution. Now, maybe, let's suppose we don't just, of course, randomly notice that the second equation is the same as the top once I multiply by -5. And so what normally happens is we solve it with substitution, and we would proceed as normal. So let's do that. If I take the second equation and I want to solve this system by substitution, I would solve for one of the variables. Maybe I'll solve for x. So how about we move the 5y to the right-hand side, which causes its sign to change, and then we would multiply both sides by a -1. And so x equals -2 plus 5y, which I would now substitute that into the first equation. So the first equation is 5x. That's going to be 5 times x, which I'll substitute -2 plus 5y, minus 25y equals -10. And now I will solve this for y. So we have distributing and notice the variables cancel out. 25y and minus 25, they cancel out. Whenever we're solving an equation and the variables cancel out, that means the answer is either like all real numbers or no solution. It depends on if I get a true or a false statement. -10 equals -10 is true. This is called an identity. And what this means is, y could be any number. Y could be any real number. So all numbers are solutions. So as soon as I see this identity right here, this would tell me that that these two lines are the same and that there's infinite solutions. If I had gotten a false statement like -10 equals 2, that would have been false. That means there would be no solution. Geometrically, those conditions are describing two lines that are parallel. They'll never intersect, and that's why it'd be no solution. So this is infinite number of solutions, so the answer choice is B. And the way we describe the solution set is in slope-intercept form. That's what they're asking us here in the directions, expressed in slope-intercept form, if the system is dependent. A dependent system is a system in which the two lines are actually the same. So all we got to do to finish this problem is take one of the equations. I'll take the bottom one because it's a little simpler and solve it for y. So we're going to put it in slope-intercept form. And now we divide by 5. So y equals 1/5 x plus 2/5. And we would type this equation right into that box.